We will deal with divisibility rules for some simple prime numbers, common prime numbers. For example, 2, I am sure all of you understand that basically even number. If it is even, it is divisible by 2. Now, the powers of 2 also operate in the same fashion. For example, when we say even, how do I identify whether a number is even or not? You look at the last digit of that number. If the last digit is even, the number is even. If the last digit is odd, the number is odd. Right? So if the last digit is even, the number is divisible by 2. So same logic will hold true for 2 square, which means the last 2 digits. For 2 cube, last 3 digits. For 2 to the power 4, last 4 digits, and so on. Which means if I have to check for 4, I just need to check the last 2 digits. If I have to check for 8, last 3 digits. If I have to check for 16, last 4 digits, and so on. Right? Now let's go to 3. 3, the rule is sum of the digits, which is also the rule for 9. This means if sum of the digits is divisible by 3, the number is divisible by 3. If sum of the digits is divisible by 9, the number is divisible by 9. Also, if a number is divisible by 9, obviously it will be divisible by 3. Now this rule can also be used to find the remainder. For example, say 7, 8, 9, 6, 5, 7. Let's take a number like this and check the divisibility with 9. If you add up the digits, what do you get? 15, 24, 30, 35, 42. 42 is obviously not divisible by 9. But if you divide 42 with 9, the remainder is 6. So we can also say that if this number, the original number, if it is divided by 9, the remainder will be 6. Okay. So this can also help us to get the divisibility rule for 6. 5 again is very simple. I am sure all of us understand this. The last digit is 0 or 5. So as in the case of 2, if 5 can be decided by last digit, then 25 can be decided by the last 2 digits. 125 divisibility rule is last 3 digits. 625 divisibility rule is last 4 digits, and so on. Okay. We'll skip 7 for a while now, so we'll go to 11. Now 11, you have to find the difference of the sum of the sets of alternate digits. The language looks a little confusing, but I'll explain what this means. For example, say 6, 8, 5, 7, 9, 4, 3, 2, 1, 6, something like this. You have to identify alternate digits. For example, odd place digits. So first digit, third digit, fifth digit, seventh digit, ninth digit. Similarly, second digit, fourth digit, sixth digit, eighth digit, and 10th digit. So you have 2 sets of digits. You add up the digits in each set. Say odd place digits. 11, 20, 23, 24. Add up the digits in the other set. 15, 19, 21, 27. And find the difference of these 2 sets. In this case, the difference is 3. This difference is not divisible by 11. So the number is not divisible by 11. This is as simple as that. Okay? You understand for 11? Alright. Now, extending from divisibility of prime, this can also be used to find the divisibility of some composite number. Say if I have to find 6. Now 6 is 2 into 3, so I have to check for both 2 as well as 3. Say 15. 15 is 5 into 3, so I have to check for both 5 as well as 3. Say 12. 12 is 4 into 3, so I have to check for both 4 and 3. Now you see, in each case, I have written the numbers in a way where the 2 numbers that are multiplying to get the number, they have no factor in common. They are co-prime to each other. So when you try to use a composite number as a divisor and you try to see whether it is dividing the number or not, then you break it up as product of numbers which are co-prime to each other. For example, if I have to check a number for 18, so I can write 6 into 3 also, but I would prefer to write 9 into 2 because 9 and 2 are co-prime to each other. So if I have to check whether a number is divisible by 18, I will check with 9, I will check with 2. If it is divisible by both of them, it is divisible by 18. Say 24. Again, I can write 12 into 2 or 6 into 4, but the right way to write it is 8 into 3. If the number is divisible by both 8 and 3, it is divisible by 24. Let's take 144. You can write 18 into 8, 12 into 12 and all, right? But you have to break it up as product of 2 prime. So 16 into 9. 16, you know the rule is last 4 digits, 9 is the sum of the digits. So this is how you can check for 100 and 144. Alright, you understand this? Okay? Alright, thank you.